Very good morning to one and all. Myself Vamshi. I am from the Triple E branch. Today I am discussing about a topic of choosing your motor. Coming to introduction part, selecting the right motor is a crucial role for success of any mechanical or electrical project. By selecting the correct motor, it is only the solution for solving any mechanical or electrical project to get generated electricity. Factors to consider include power requirements, size constants, and environmental conditions. The motor has a separate specific features which has power requirements which is to be suitable, and size constant and which is size or bigger or smaller, and which it is environmental condition is or not. Understanding the different types of motors available is essential for making an informed decision. By understanding the motor only we can do anything on a mechanical or electrical project by easily. Types of motors. The most common types of motors include DC motors, AC motor, and stepper motor. There are the types of motors which are commonly used in our day-to-day life. It is DC motors and AC motors and stepper motors. Coming to DC motors are typically used in applications that require speed control of an high torque. DC motors are highly used because require speed control and high torque. And the second, coming to AC motors, which are suitable for constant speed applications, while stepper motors are ideal for precision positioning. AC motors are suitable for constant speed applications, which will be speed will be in constant. And while coming to the stepper motor, it is for ideal precision positioning. And the power requirements for motor. Determine the power output needed for your motor based on the specific requirements of your project. The power which is giving input and output will be there will specific requirement for your project. Consider factors such as voltage, current, and power efficiency when choosing a motor. We have some factors for the motor for finding it: voltage, current, and power efficiency. Select a motor that can handle the maximum power demand with overheating or malfunction. The motor which we have to select that which the motor which does not have any overheating or malfunctioning. Size constants. Take into account the physical dimensions of the motor and ensure it fits within the available space. Consider weight of motor as well. Consider weight of the motor as well, especially if the application requires. Consider weight of the motor as well, especially if the application requires portability. Choose a motor size that balances performance with space constraints for optimal functionality. By selecting the size, it is the very crucial plays a crucial role for selecting motor. Uh, for for certain motors, it has some specialization for given space or a size, torque and speed. Torque is the rotational force produced by a motor, while speed refers to the rotation per minute. RPM means rotation per minute. It is a force produced by a torque. It is a force which is produced by motor. Select a motor with the right balance of torque and speed to meet the requirements of application. Select the motor with right balance of torque and speed to meet the requirements of your application. Consider factors such as load capacity. Consider factors such as load capacity and acceleration while evaluating the torque and speed capabilities of motor. Depending upon the motor only, selecting only, we can evaluate the torque and the speed and the load which will be possible to that load motor, which will be conclude from that. Efficiency and power consumption. Efficiency is a measure of how well a motor converts electric energy into mechanical energy. Efficiency is nothing but a motor which converts electric energy into mechanical energy. A motor is it converts electric into mechanical energy, and a generator is mechanical to electrical energy. Choose a motor with high efficiency to minimize energy waste and reduce operating cost. By selecting the we have to choose the motor which has high efficiency, because the energy waste will be there. Because of the reason, we have to choose a higher efficiency motor. Consider power consumption of the motor over time to assess its long term impact on energy usage. Power, Consider power consumption of the motor over time to assess its long term impact on every usage. Environmental conditions. Evaluate the environmental condition in which the motor will operate, including temperature, humidity, and extractors. and a motor which will be react to the temperature and humidity and X expose which will be no. Select a motor that is designed to withstand the specific environment and factors of your application. Main thing you have to do that motor will be selected which will be environmental freely and it will no damage for a longer time. You have to select that motor. Consider the additional protective measures such as enclosures or cooling system for motor used in harsh environment. In case of we use motors in harsh environment in stove and in motor, we have to use for and in temperature high temperature we have used cooling systems for motors. Control option: determine the level of control needed for your motor such as speed control, position control or directional control. Choose a motor with compatible control options such as PWM pulse width modulation or PID control. We have to choose the motor with compatible control options such as PWM and the PID. Consider the compatibility of the motor with the control system used in your project for seamless. Compare the cost of different motor options to find the best balance between quality and affordability. Application examples: motors are used. Application examples: motors are used in wide range of applications including robotics, automotive systems, industrial machinery, and consumer electronics. Motors are used in various applications such as include robotics and automatic systems and industrial machinery and consumer electronics. Each application has unique requirements that dedicate the choice of motor type, size, and performance characteristics. For different requirements of application, this choice of motor types as such, size and the performance characteristics and the supply and the input and the output will be depending upon the motor. Study real-world examples of motor applications to understand how different motors are selected for specific use cases. Maintenance and serviceability. Consider an ease of maintenance and serviceability when choosing a motor from your project. And maintenance and the service will be choosing the motor will be cheap and to select that. Select a motor that allows for easy access to components for inspection and repair on placement. If the motor gets repaired, we have to select a motor which is will be easy to inspection and to repair and will be suitable to convert to work easily and replacement. Ensure that the replacement parts and service support are readily available for the chosen motor to minimize the downtime. But selecting the motor which is will be get repaired and we have to select the we have to readily available for the motor parts. Because of this only we can minimize the down load time. We can easy to do that. Noise and vibration. Motors can generate noise and vibration during operation which may impact the performance and comfort of the application. Motors generate noise and vibration because during operation this will be noise and vibration during operation which may impact your performance and comfort application. Choose a motor with low noise and vibration levels to ensure a pleasant user experience. We have to select the motor which will use a low noise and low vibration levels. With this only we can use the motor as a pleasant user. Because of the heavy sound it will be disturbs the whole. Consider mounting and isolation methods to reduce noise and vibration transmission into the surrounding environment. By using the mounting and isolation method, we can reduce the sound and the vibration of the motor. Testing and evaluation. Conduct thorough testing of the motor before integrating into the final system to ensure proper function. Conduct the motor running firstly because by seeing that only we can conclude it to the final system to proper functioning it is working or not properly. Evaluate the performance of the motor user under different operation conditions to validate is suitable for the application. A motor will be used for different operating conditions to validate suitable for the application. Use testing data to fine tune of the motor, control parameters and optimize the overall system performance. Future trends. future. The motor industry is constantly evolving with advancements in technology, materials, and design. It is a very advancements technology with the future trends, materials, and design. Keep abreast of future trends such as smart motors, energy efficiency designs, and integration with IoT, Internet of Things systems. Consider the potential impact of emerging technologies on motor selection and implementation of future project. In future trends, we get in future also we are getting many of the updated motors to use for different purposes in cars, etc., in machineries, etc. Conclusion: choosing the right motor requires upgrades to requirements understanding of the application requirements and motor characteristics. Consider factors such as power requirements, size, constant torque, and speed capability, and environmental conditions when selecting a motor. Be careful evaluating these factors and making informed decisions. You can ensure the success of your project with the optimal motor choice. By selecting a right motor, it is a success for the our project which we are doing, and is a motor as a high efficiency and a low cost and easily available in the market, and the parts which are be repaired, it will be able to available in market easily. With this only we are success our project. Thank you.